am Sandhya, Assistant Professor, Department of Mathematics and SNS College of Technology. Today we are going to see Laplace transform. First, Laplace transform is f of t be a function of t. So here f of t is a function of t defined for t greater than or equal to 0. Then the Laplace transform of f of t is defined by. So how we can define the Laplace transform of f of t in mathematically? L of f of t is nothing but interval 0 to infinity e power minus st f of t into dt. Okay, so L of f of t is 0 to infinity e power minus st f of t into dt. So here the L of f of t is nothing but L of f of s, that is capital F of s. Okay, L of capital F of s. So here L of f of t is nothing but L of f, capital F of s. Okay, then we have to solve the exponential order. So exponential order is nothing but limit t tends to infinity e power minus st f of t value is exactly equal to 0. If it is equal, the values final solution is 0, it is an exponential order. If it is the final values for the number 2, 3, 4, it is not exponential in order. So see the example for the exponential order. Here the first example is t square is, so here the function f of t is t square is exponential order. So the final solution is we get the 0 if it is an exponential order. Otherwise if it is the value get 1, 2, whatever it is, so it is not exponential order. So our question is t square is exponential order, so the solution is 0. So here we have to prove it is 0 or not. Okay, so here limit, so what is the that is exponential value, that is limit t tends to infinity e power minus st f of t. Okay, see here replace f of t is t square, that is limit t tends to infinity e power minus st. So here the f of t value is t square. Then here limit t tends to infinity, we have to replace this by t square divided by e power st. Then substitute the limit here t tends to infinity. So we have to replace t instead of infinity divided by infinity. That is infinity divided by infinity. So we have to apply the L'Hospital rule. So what is the L'Hospital rule? So one time differentiate with respect to t. Okay, so you get some answer, but it is infinity value. So we have to using the L'Hospital rule. So one time differentiated with respect to t. That is t square is 2t. Then here e power st differentiate with respect to t. So e power st then yes. So then again we have to substitute the infinity value. That is 2 divided by infinity. So here 2 divided by infinity. Okay. So then we have to substitute anything divided by infinity, the value is 0. So here the value is 0. So here the t square is exponential in order. Okay. Example of exponential order. So here t square is exponential order. So see another example of it is not exponential order. E power t square is not exponential order. So here using the exponential order condition, what is the condition? Limit t tends to infinity e power minus st into f of t. Okay, so here again we have to replace f of t is e power t square. Okay, e power t square. Okay, then here see base is same, adding the power. So that is e power minus st plus t square. Then replace infinity. So what is that? So here e power minus infinity plus infinity square, that is minus infinity. You know e power minus infinity value is infinity. So the answer is infinity. So if it is 0, it is a exponential order. So our answer is infinity. So it is not exponential in order. So the exponential order is exactly the value is 0. That is limit t tends to infinity e power minus st f of t value is 0. Okay. Then we have